series solver. So given an input string sequence, the task is to find the odd one out by checking the difference between adjacent letters. The elements having a distinct difference is the odd one out. The element having a distinct difference is the odd one out. Okay, by checking the difference between the adjacent letters. So given a series ACB, BDC, CED, DEF, in this we can observe that in the ACB, BDC, CED, there is a pattern of the first letter. ABC. Okay, there is a pattern of the first letter. The next first letter, the next to the next letter of the first letter counted alphabetically, and the next letter. But DEF has not that such pattern, odd one out. Okay, need to pick odd one out. So input string. The input string is just the first line contains an integer n. So integer n denoting the number of elements in series. Each of the subsequent n lines, okay, we have given with the series in this function definition. Okay, A B C D, B C D E F G H D C D E. So answer is D C D E. Okay. Okay. Okay, we'll do one thing. We'll store those sequences. Okay, in this one also ADC, BGD. Answer is FGH. FGH. Okay. We need to pick that odd one out. So first of all, we have given with a series. Nothing but a list. So in Python we have list, right? So we have given with list as a parameter series. So first what we'll declare a list to append all those difference elements into this. So for word, we have words, right? For word in series. For word in series. So we need to print the difference of each letter in that particular word, right? So what I do means so okay, what I do means first of all I'll take a word and find those differences of that particular word. So let's say we have a length. So to find the difference between keywords, let's say we need to find the odd one out by checking the difference between adjacent elements. So adjacent elements difference should be considered, right? So ADC means A minus D, D minus C should be calculated. So n minus number of times should be calculated. So for I in range of length of word minus 1, right? So in that particular length, so I'll declare a temporary variable which is a list. So now what I'll do means I'll store the differences. So for I in range of length 4 minus 1, let's say we have the difference ADC, length minus 1 is 2. So 3 minus 1 is 2. So 2 means zeroth index, so we have two. So like 2, 0 and 1 are there. So 0 and 1. Here we'll do 1 and 2. Those are the indexes that we need to make the difference. So what I'll do means temp dot append of abs of word of I minus word of I plus 1. That is stored in the temp. Later, after completion of that particular word, I'll add that word. I'll add that words into my list. List dot end of word. I'll do one thing. I'll convert, instead of doing this one, I'll do strings. Do it in strings. Strings is a better option. So what I do means, so I have taken a temp, and instead of doing this, I'll do temp plus equals to str of temp plus is equals to str of abs of word of I minus word of I plus 1. So it's converted into string, and later that is concatenated with the empty string. So it is being now that is being appended to our list. So list dot append of temp. So I'll append that to my temp. So I have the list with all those differences of words, right? So now what I'll do means, for I in, so I'll check 2 as my window. I in range of length of list minus 1, right? So if list of I not equals to list of I plus 1, so now I need to pick the odd one. So I do one thing. I'll simply do from collections import counter. So counter will make our things pretty easy. So what I'll do means dictionary. So dictionary has the properties of count, check the frequencies. So counter of my list, right? So what I do later in the dictionary means using of the variable dictionary with I comma j. So I is the particular value and j is that particular words frequency. So how many times that is there in that one. So for I comma j in dictionary dot items, so those things are being added. So I'll do dictionary dot sort. So the dictionary is being sorted. So to make it as frequency sort, do j comma I, since our frequency is j, right? So it's sorted in the form of dictionary. So after this sorting is completed, I'll just return So now our dictionary is nothing but list. So I'll do dictionary of zeroth index as the first tuple. So in that tuple, J is the index and I need the I1 means second part. So first part is the J part in the tuple. Second part is the I part. So I part is what we want, whereas the J part is the frequency. So by making sort according to the frequency and taking the I means first index. This is the zeroth index. This is the first index. So we're returning the first index. So we'll check it how it works. Okay, this runtime error. M plus is equals to star of. Okay, OABS of word of I minus. Okay. We need to take before adding, we need to convert that into the ASCII value, right? So we need to convert that into ASCII value. So odd function converts the letter into the ASCII value. So we'll check it now. So we are getting as 11 as answer. It is DCB. So 11 means 1. I'll do one thing instead of returning value. So okay, I'll return this one value as well. I'll print the dictionary. So in dictionary, what is there, like values and count is there, right? Values and count is there, right? Temporary. But we need that particular word. So we need to take the word, right? So instead of doing this, I'll do one thing. I'll declare temp with array. So I'll do temporary dot so okay, let the temporary value be that only. So temporary value is nothing but yeah, temporary is that string. So when I am taking the string, what I'll do means I'll even not only take the temporary, even send the word also in that. Yeah. Yeah, I even send that word also. So even send that word also. So now what I'll do means, so our like our word is present as the secondary part, while our temporary is present as our first part. Right? So we need to match up these things. Right. So yeah. Okay. My temporary and what is being added. Instead of this, what should I do in another thing? Means do one thing like I take dictionary here itself. So for not, if temporary string is not in dictionary, suppose if temporary thing is not in dictionary, okay, am not in dictionary. So if that is not in dictionary, I'll do dictionary of that temporary equals to 1. I'll count this one here itself. Else dictionary of s equals to 1. So I'll get a dictionary, but I need to take that one different values word, right? Yeah, I need to take the different values word. Okay, instead of I don't taking this, so I'll do temporary is that difference string. I'll just do one thing. I'll append the temporary the word as well. Word as well. Okay. So temporary and word are being added. Now I'll iterate. So my list is now populated. Right? So what I'll do is for let's say I have the first element as the different one, second element as the next element one. Okay, dictionary. Okay, dictionary has those list has those values, right? So if my first one is different with the second one, first one will be the answer. Suppose if my second one will be different, second one should be my answer, right? So, but how should I get means? So I'll do one thing. For pull in list, so I start from one element, right? So I will take previous is equals to, right? Previous is equals to list of 0. So list of 0 is that tuple, right? So for tuple in list, so now I need to compare that one with other elements as well, right? for tab in list of 1 is to, for tab in list of 1 is to, if, so I'll check, I check with the value. So if previous, so previous is the list of 0, means tuple with which contains that temporary difference, the elements difference array in array plus the word. So word is situated in the 1th position. So 0th position the temporary is present. So if previous of 0 is equals to of 0, if this condition is happened, let's say previous is one of the same element in that element, I'll just do one thing. So if this is the case, so I have two cases now. So one is like my first element should be a different element, otherwise first element should be some like same with some elements, right? So I have two conditions, so I need to make up that conditions. So let's say I have the same element with in which all the other elements are being there, right? So I'll do one thing like I'll sort the array. If sorting will help. Yeah, like sorting might help or not. Not sorting like. I'll do one thing. Use dictionary concept. So without using this count, let's say I'll declare a dictionary. So I'll declare a dictionary. No doubt with that. Now what I'll store means I have temporary. I need to count how many temporaries are there. Okay, I have two values, right? So let's say I have previous. Previous is equals to my list of 0. So I'll do one. So 1 comma. So 1 comma 2. That these two will be answers. 1 or 2. So for up list of 1 is to second element onward. So declare 1 is equals to so I need word, right? I need the word. So 1 is equals to previous of 1. If 1 no if previous if 1 not equals to, right, 1 not equals to the of 1, of 1, 0, 1 is the word, next word. So in that case, my 2 means the second word. Then my second word should be of 1, and I will break out of this one. Simple. Right? So I'll be remained with two different values, 1 and 2 different words. So for I need to check the words, this one, right? One is list of one, one is list of one, previous of one. To check with the temporary slide, right? So if previous of 0, first element, not equals to up of 0, that would not that string evaluation not equals to this string evaluation means the difference string. So then I'll do 2 is equal to top of 1. Right? So 1 and 2 are being declared. So I'll break out of that loop. So I have the two different words, right? I have extracted the two different words, 1 and 2. So yeah, one is the previous one, the word, that's a different word, and this is the different word. So I don't want that word, right? Okay. I'll do one thing. 1 is equals to is previous, right? I'll take the whole tuple. So if previous of 0 not equals to top of 0, then 2 is equals to whole tuple is being loaded. So my 1 and 2 is also a tuple, which has the first in the so it's a set of two values. It has first as the temporary that different string, later the word. So words we check for the strings, later we'll do that words. So now for counts I declare count 1 equals to 0, count 2 equals to 0. Try in list for tuple list. So the tuple if top of if 1 equals to, so 1 is the previous is nothing but the list of 0 whole. So if 1 of 0, like right, if 1 of 0 equals to top of 0, so that strings, so I'll do count 1 plus equals to 1, elif if if 2 of 0 equals to top of 0, I'll do count 2 plus equals to 1. So these two conditions are enough. So we'll calculate the counts. If count 1 less than count 2, so if count 1 is less than count 2, then we'll return 1. 1 is the tuple. So what we need to return? The word. So 1 of 1, else return of 1. I think this might work. I'll remove all this stuff. So this condition is also not needed since we are in a function definition. Then good. Oh shit. Unbound local error. So I'll do one. Good. 11 line 60. BC. 11 ABC. 11 means 1 1. ABC. What's that ABC? Hmm. 11 ABC. 11 ABC. Nothing is present in 2. So nothing is there in 2. Why nothing is there in 2? ABC, BCD, EFG, DCB. Okay, that's the problem. You should not be able to use ABS. ABS use, you should not use that ABS. I'll run my code. -1, -1, -1, -1, -1, -1. No, 1, 1. That's the blackfish. So then this is not needed, I think. Yeah. Okay. A top pin list if count of 0, that should work. DCB, test cases. So -1, -1, -1, A, B, C, D, F. This one, B, C, D, this one. So like this. So my output is TSRQ. Of 0 is equal to top of 0. Count 1 equals to 1. Technically, this should work fine. Okay, I'll remove this debug options. Yeah. So actually, the problem is it's difficult, but it can be manageable. We can do that. Yeah, it's just finding the odd one out. So first I have declared the list. Later I'll uh, I loop to over this series with the name word. So for every word we have letters, right? So I declare temporary string as empty string. So I'll loop over every word and I'll find the difference between that words ASCII value. So odd of word I minus odd of word of I plus 1, thus next letter. So I'll found that difference and I'll convert that part into a string so that I can concatenate to my empty string. So after completion of all those things, after all the completion of the letters in that word, I'll append my temporary generated string, which is the difference of that letters along with the respective word as a tuple. Now I'll append that into my list. So after that, I'll do the same thing for every word, like temporary difference letters string, ASCII values difference string, and the respective word. So after I'll do that appending to my list. After the completion of whole this thing, I'll take previous as pre equals to list of 0, nothing but the first tuple, means first temporary and word. I'll declare that. Later I declare 1 to that variable. So I should have two different values, right? So one is different with all those things, all other values, and all others I pick one value from all other things. So up in list of 1 is 2 means I'll index from 1, since I have already used the 0th index. So whenever I found these two are different, my second different element is I have successfully found that my second different element. So I'll break out of this loop, declare two counts, count 1 and count 2. So whichever has the count as 1, right? Whichever has the count as 1, that should contain the distinct variable, right? So whenever I found count 1 as 1, so 1 of 1 is my answer. Otherwise, I'll return count to 2 might be equals to 1. So I'll do count of 1. So that's what I have written. So why I have written 1 means in my tuple, the 0th index is the temporary difference ASCII value string, whereas the 1th index position has the word. So we need to print the word, right? So word is being successfully printed. So now I'll run all test cases. Yeah. Now I'll submit as well. Now I'll take the second problem. In an astronomy board game, planets in an imaginary universe do not follow the normal law of gravitation. All the planets are positioned in a row. Okay. Astronomy board game. It's a board game. In planets in an imaginary universe. Imaginary universe. And planets were there. Imaginary universe do not follow the normal law of gravitation. So we don't follow the normal gravitation. All the planets are positioned in a row. So it are positioned in a row, one by one manner. The planetary system can be in a stable state only. So we say that the planetary system is stable only if the sum of the masses of the planet at even positions is equal to the sum of the masses of the planets at odd positions. So the planetary system is said to be stable only when we say the even positions mass should be equal to the sum of the odd positions mass. So both mass should be equal. Then we can say that planetary system is stable condition. Initially, the system is not stable, but a player can destroy one planet to make it stable. Okay. Find the planet that should be destroyed to make the system stable. Okay. If no such planets exist, return -1. Okay. If there are multiple such planets, then destroy the planet with the smallest index. Okay. Return the index of the destroyed planet. Okay. So index of that destroyed planet is printed. So if nothing works, nothing not if we don't find tried for every planet and we destroyed for every planet but nothing works, then we need to return -1. So that is not possible condition. It's a not possible condition. So we have given with an example, n equals to 5 2 4 6 3 4, destroying the fourth planet of the mass 3. So this is the fourth planet of mass 3. Mass 3, right? When it should be destroyed, we are left with the planets like 4 6 4, right? And here the sum of odd position planets, that is 2 plus 6 is 8, and the even positions 4 plus 4, that is should be equal. Okay. Sum of the even position. Okay. So even position is possible. So we have destroyed the position called 3, right? So the position is 4. Since we destroy the fourth planet, so we need to output 4. So we have given with input first line of input contains n, denoting the number of planets, each line n subsequent lines. So already those were taken were as planets as a list and given in the form of function definition. So now we need to do this. So we have the planets as 2531. So let's check. 2 plus 3 is 5, whereas 5 plus 1 is 6. So let's say if we remove the planet 2, so 5 plus 1, that is 6 and 3. So let's say 5 remove. Let's say we have removed 5. We have removed this 5. So 2 plus 1, that is 3. And 3. Cool. Right? See here we have, when we remove this number 3, we are left with these values, right? 2 plus 6 is 8 and 4 plus 4 is 8. So same in this manner, output is 2, means this index 5 is removed, so that we'll get 2 plus 3 is 2 plus 1 is 3, and the 3 is also is equal to 3. So we need to find that. So first what I'll do means so planets is the original one. So I'll take one temporary for the planets, right? Temporary equals to planets dot copy. So I'll copy that one. So I'll copy that one, right? So after copying that one, so my temporary, so I don't change my planets. My temporary is now being changed, right? My temporary is being changed. So first for remove the, so first I need to remove that particular item, right? So let's say we have 4 items. So I take n as the length. N is equals to length of planet. So that's the length of planet. So if I have removed the first element, we have left with 3 elements. So I can remove 4 times, right? For every time I can remove 1 element in my particular list, right? So for I in range of n, so n is nothing but my list. So temporary is equals to planets copy, that is being copied. So so my I is presently at 0, index 0, right? So now I left the zeroth index mark, right? So I'll do my temp is equals to temp of 0 to 0 plus temp of I plus 1 lost. Right? This is cool. It will be set. So from index 0 to what I'll take for 1. So later I'll do 0 plus 1, that is 1:2. Even when you even when you check for I is equals to 1, suppose let's say my I value is 1, so my temp should become, so my what my temp should become like is to 1, right? Is to 1, here is to 1, and here I plus 1, that is 1 plus 1, that is 2, 2 is to last. So my index 1 should be left, right? So from 0 to 1 means 0 is included, 1 is not included, 0 is included, and from 2 is to the rest of the part is included. So it should work for the every index. So now I have taken the temporary as well. I'll declare a function definition to check for the sum in the even and odd places. So I'll take the value as r, though that's an array. So I'll check for the even and odd places. So I'll declare two counts. So count 1 equals to 0 and count 2 is equals to 0. So for I in range of length of array, right? If I percent 2 equals to 0, that is 0, 1, 2, let's say the odd indexes. So one in general case we'll take as 1, 2, 3, 4, but according to the Python, indexes start with 0, right? But according to the problem statement, first index start with 1. So I'll do count 1 plus plus 1. Else in that if it is not possible, in that case do count 2 plus is equals to 1. So I'll just return count 1 equals to count 2. Both are equal, 2 will be returned. If not, false will be returned. So I'll check flag equals to flag equals to check of temp. So if flag, say my flag is true, so I'll previously declare my flag as false, right? So if my flag is true, I'll just break out of this loop. Means I have found my answer. By destroying that one, I had got that like answer, right? So like I had got that answer. So I take answer is equals to I plus 1. I plus 1. That's destroyed elements answer. Right? Cool. So whenever the flag is true, break out of that loop, right? So whenever I see flag is true, then I return answer. Answer is nothing but I plus 1. If not in that case, means I have looped over all the things, but I found nothing. So I'll return minus 1. So let's check with this code. So I am getting minus 1. So where it's going wrong, expected output is 2, but I am getting as 1. Yeah. So let's don't interfere with this. So what I am sending the input is 2531, right? 253. Okay, cool. I'll do one thing. I'll print all my temps, how my temp is being regarded. So I'll just at last run for it minus 1. So I get 531. So first 2 is deleted. Later 5 is deleted. I get 231, right? 231. Later 3 is deleted, 251. Later 1 is deleted, 253. Okay. This output is correct. Fine. So I'll even print flags. So is my flag working correctly? No, it's coming as false for every output. Okay, it's coming output as flag for. So the problem is with this one, right? So the problem is with this one. Okay, count not. I need to take the sum, right? Yeah, sum one and sum two. Sum one plus equals to the array of I, and here sum 2 plus equals to array of I. Finally, I check with sum 1 equals to sum 2, right? Yeah. Now I'll print flags. Yeah. I'll print flag. Here I update the flag as flag equals to flag of just for the namesake. I'll return 0 to return any integer, right? Whether all flags are true, whether all flags are false or not. Yeah, one flag is true. So this is what we are expected. Yeah. So what I'll do now means if flag is true, then break out of that loop. So I have break out of the loop. So whenever I found that flag as true, right, I'll return answer. Answer is nothing but I plus 1. If I don't find that one, means after looping through the all elements of the array, I don't find any sum 1 equals to sum 2. Then in that case, I'll return minus 1. So now I'll do. Hopefully this test case ending. Now I'll run all test cases. Yeah, it's taking time. Yeah, it looks like time limit exceeded. 11, 12, 13, 14. Okay. 4 test cases are being time limit exceeded. Okay. Like what I can do here means yeah, I'll do one thing. I'll take whole sum. Sum is equals to sum of planets. So I'll remove half part of that. Yeah. So I need to find the planets for everything, right? For every time I need to, the odd and even places should be shuffled at every part of the time. So temp is equal to temp is equal to planets dot copy. So I'll do I'll do one, yeah. So I'll try with pi3. Pi3 is much faster than Python 3. So I'll check with this. Yeah, works fine. Yeah, same thing is happened here also. Yeah, we need to copy all the elements into temp of the planet. So later temp is being updated. So instead of this type, can we do like any other stuff? Can I do any other stuff like I have 2 5 2 5 3 1? Yeah, I have 2 5 3 1. So let's say my even and odd sum is being calculated previously. So my 2 plus 3 is 5 and my 5 plus 1 is 6, right? So when I remove the 2, right, my when I remove the 2 when I remove the 2, suppose I have removed the 2, so I have left with 531. So 531 means, so I need to remove that 2 from 5, right? 5 minus 2. So I'll get as 3. So in this case, so in that case, that is okay. When I am at odd place, let's say I am at 5, so I'll do minus 5. So minus 5 do this. So 2 plus 3 is 5 and 5 plus 1 is 6. Suppose 5 is removed from the second part. So 6 minus 5, this becomes 1 and this stays as 5. So 2 plus 1 is 3, right? 3. So okay, it's an odd even. It's an odd even. Like odd even distraction. What I need to think like I need to maintain the sums. So instead of always calculating the sums again and again, I need to previously maintain the sums. Yeah. But how to do this means, let's say I have 2, 5, 3, 1. So I have the even sums as 2, 3, that is 5, and 5, 1, that is 6. So if I have removed the 2, I have left with 5, 3, 1. So my events are 5 and 1. My odd is 3. So I have removed 5. Let's say I have removed 5. So I have left with 2, 3, 1. 2, 3, 1. So the actual sums are 5 and 6, right? So actual sums are 5 and 6. Yeah. I'll get to this point. So instead of calculating all those things. So 2 plus 3 is 5 and 5 plus 1 is 6. Those are the absolute primary sums. So let's say I have taken the test case as 2, 3, 2, 5, 3, 1, right? 2, 5, 3, 1. Yeah. 2, 5, 3, 1. So this one, 2 plus 3 is 5. That's the first sum. Later we have the second one as 6. That is 5 plus 1. Let's say I have removed the 2. So I'll get 5, 3, 1. So how I need to change this sum values means, so I have to remove one value from the first one. So first sum 1. So let's say this is sum 1. This is my sum 2. So since I have removed the first value, I remove the 2 from the sum 1. So I remove the sum 2 from the sum 1. I'll get 5 minus 2 as 3, and my sum 2 remains the same. So only sum for everything, for every iteration, only one sum is changed. The next sum is being not changed, right? So if I have removed the 2, I'll left with 5, 3, 1. Suppose if I have left the second element, that is 5, that is in position index 1 element, we'll get 2, 3, 1 as the value, right? Yeah. So what I do from this means, so let's say you have previous sum as 5 and 6. Does these things work here? Yeah, they'll work. So you need to not change the sum 1, but you need to subtract the second sum with the, you have a secondly removed value, that is 6 minus 5 is 1. Yeah, cool. So let's say you have moved the third element, that is this one, number 3. I have left with 2, 5, 1, right? 2, 5, 1. Obviously I'll be left with 2, 5, 1. So now I'll need to remove from 5 and 6. So sum 2 is now completed. Now I need to concentrate on sum 1. So sum 1, so I have removed 5 minus 3. Like I'll be left with 2. This one is unchanged. So yeah, I got some idea from this. So now I don't use this function definition. First I'll do for I in range of n. For I in range of n, I declare two variables. Sum1 equals to 0, sum2 equals to 0. Sum1 and sum2 are being declared. Okay. So sum1 plus equals to okay. If I pass and 2 equals to 0 means the sum1 index start from 0, right? So I'll do sum1 plus equals to planets of I, right? So if that's the not condition, we landing on the indexes like 1, 3, those indexes. So planets of I. So I have populated to the planets and I have got the two sums, even and odd sums, right? So I have got even and odd sums. So after every iteration, so sum1 and sum2 is being like generated. So what I'll do means I'll so even copying is all this stuff is also not needed. Yeah, I guess this stuff is also needed. So I'll do sum1. So in first iteration, if I% 2 equals to 0, sum1 minus equals to, so my original sum should be not removed. Yeah, my original sum is not removed, right? So instead of for that purpose, I'll declare temp1 and temp2 as sum1 and sum2, sum1, and my temp2 as sum2. So if I% 2, then temp1 minus equals to planets of I. So that is being removed. So but temp2 is stays alive. So temp2 is that previous value. Else in that case I'll do temp2 minus equals to planets of I. Yeah. So given index position means starts with 0, right? So I'll remove the first one. Later I'll remove the second one. And the next iteration, I'll replace the temps with the previous sum1 and sum2 values. So in any case, I found temp1 equals to temp2. So in any case, I found temp1 equals to temp2. I'll do flag equals to true, and I'll just break out of this. I'll just break out of this. So after completing that one, if I found flag, yeah, flag. If I found my flag is true, I'll return my answer. So I'll update my answer as I plus 1. Right? Good answer. If I don't find anything, I'll just return -1 if you want this stuff. Okay, now I'll check it. Oh, 4. So if I remove the index, I need to do the to someone is temp1. If I remove this one, I'll need to do something to temp2. So if temp1 equals to temp2, so equals to I plus 1 written answer. And just do one thing. I'll just print the temp1 and temp2 for every case. I just written 0 for this now. So my temp1 and temp2s, I'll get my temp1 and temp2s. So this is my first value, 3 and 6. Later this is my second value, 5 and 1. Later this is my third value, 2 and 6. Yeah. Let's see, I have removed this one, right? I have removed here, right? So 5 plus 1 is, yeah, 5 plus 1 is 6 and 2 plus 3, 2 is removed. So in my first case, I have removed 2. So 5 plus 1 is 6 and 3 is not possible. When I remove the 5, 2, 3, 1, 2, 3, 1. So now what I should get means 2 plus 1 is 3 and here you need to get 3. Right? 2 plus 1 is 3 and 3. So here what you are getting 5 and 1. That's completely wrong. 2, 5, 3, 1. So can I do anything with these two? 3 and 6. First condition I have reduced this. In second condition I need to do 3 here, 3 as the previous one. So coming to this condition, 3 the previous one and here also 3. So So let's say I have 2, 5, 6, 7, 8. So I'll calculate for this one. 2, 5, 6, 7, 8, 4. So first I'll calculate the sum one and 2 as 2 plus 6 plus 8. 2, 6, later 8. So 6 plus 2 is 8. 8 and 8, that is 16. 2, 6, 8 or 16. 16. Later 5, 7 and 4. So 5 plus 7 is 6 2s are 12, right? 7 minus 5, that is 2. I'll send this 1, 2, 5. So 6 plus 6, 12. 13, 14, 15, 16, 16. 16. Yeah, means previously it's yeah. Suppose let's say first one 2 plus 6 plus 8. Okay, 16. Later 5 plus 7 plus 4, that is 16. So we got 16 and 16. Remove the first one. 5, 6, 7, 8, 4. So I need to maintain 16 minus 2 as 14. In the next iteration, 5 is removed. 2, 6, 7, 8, 4. So now 2, 7, 4, that is 4, 5, 6. 13. Here 13 and here value is 14 here. Now I need to change the 16 minus 14. So 1 is 14, no change in that one. Like 2, 7, 4, 7, 8, 9, 10, 11, 12, 13, 14. Plus 8 is 14. So here the removed element is here nothing was removed. Here the removed element is 5. Here the removed element was here the removed element was 2. The removed element was 5. So how can I get 13? can I get that? Five minus two is three. Yeah, 5 minus 2, that is 3. Add that 3 to this one. Later 26784 later what will you get? 25784. So 274, 7, 8, 9, 10, 11, 12, 13, 13. It is 13. 5 plus 8, 8. Here also 13. What's the removed value here? 6. Okay, up to here no problem. You can get 13 here means 13. Yeah. So 14, 6 is the first value. Later, after removing minus 2, how you can remove the minus 2 means just first shift this someone to come to. Later, the presently removed value minus the previously removed value. That is 5 minus 2, 3. You need to remove 3 from here. 16 minus 3, that is 13. Later, crisscross the values. After crisscrossing the values, now you need to do 6 minus 5, that is 1. 1. That is 14 minus 1, that is 13. Yeah, this is the point what we want. So here, what the previous point is 0, right? Minus 0 is 2. So first we need to remove that one from first one. So from first someone, later I need to do that minus in the first one. Yeah, I can do either like I have observed the thing that I now I need to implement this thing in this. So one time the left side element, one time the right side element. Means the left side element only. So after everything we need to swap those things. Yeah. Yeah. So I'll maintain previous is equal to 0, right? So now I have sum 1 and sum 2. So now I'll do the operation on sum 1 and sum 2. So if I% equals to 0, I need to do on the operation on the first one. So every time the operation is being done on first element, right? Yeah. See here, see, first element operation is done. Later the operation is being done on the first element, which is swapped one. First element, but that is swapped. So later on this one, which is swapped. So swapping is okay. We can do swap for every iteration. So I need to do sum1 equals to sum1 minus equals to what I need to get minus subtracted from sum1 means my present I value, that is planets of I minus the previous value. So 2 minus 0, that is 2, subtracted from the sum1. So after subtraction, if I found sum1 equals to sum2, then I'll do return I plus 1. Yeah, if that condition is not happened, then I need to swap sum1 comma sum2 equals to, now sum1 is equal to sum2 and sum2 is equals to sum1. Now I'll swap those things. So after swapping, I'll get 14 and 16. So primarily my sum1 and sum2 are like 16 and 16. So after that, sum1 is getting subtracted. My sum1 is 14 and my sum2 is still 16. So later, after I have done the swap, my sum1 is updated with 16, my sum2 is updated with 14. Right? Yeah. So after I do sum1 minus of planets of I minus previous. So I need to update my previous. Previous is equals to the planets of I. Planets of I. And planets of I is 0 previously, but present my planets of I is 2. So 2. So what I'll do is sum1 minus planets of I. Planets of I means in the second iteration, right? So second iteration planets of I is 5. So 5 minus 5 minus previous. Previous is my previous planets of I, that is 2. 5 minus 2, that is 3. So okay, that is 3. So that is 3, right? So my sum1 is now 16. 16 minus 3, that is 13. My new sum1 and sum2 are 13 and 14. Now I'll swap those things. So my sum1 is 14 and my sum2 is 13. After that, I'll update my previous as 5. So now I'll do previous after that sum1 equals to sum2 check. Later sum1 equals to 14 and sum2 equals to 13, right? So 14 minus of planets of I. Planets of I is 0, 1. Okay, 1 is completed. 1 is being completed. Now 2, 2, 2, 0, 1, 6, 6. So 6 minus 5, that is 1. 1, right? Planets of I minus previous is 1. So sum1 minus 1. Sum 1 is 14, 14 minus 1, that is 13, and sum 2 is 13 as well. So sum 1 plus sum 2, that is true. So we don't even require this variable. So if I doesn't find anything, just return -1 here itself. Comment these things down. So I think this should work. Hopefully this should work. Yeah. Yeah, now I'll run all test cases. Cool, amazing. So actually my solution is pretty simple. So previously I have written that for every iteration I have calculating the sums of even and odd places. So instead of doing that, I have found this analysis by taking these two test cases. I have analyzed that. So this is the present without deleting any element of that array. So let's say I have deleted the first element, that is 2. So the remaining array is 5, 6, 7, 8, 4. So this is the even sum and this is the odd sum. So we have taken those things. So let's say we have calculated these two sums. Now since we have removed the 2, so my even sum means 0. That should be deleted from this. So 16 minus 2, 14. I have left with 2. So after this iteration, swap these two things. So 16 is gone here and 14 is gone here. So crisscrossly I have swapped these things. So in that next iteration, now I'll left over I remove the 5 and the remaining things will be same. So 2, 6, 7, 8, 4 are same, right? So now how I'll get 13 means 13 is actually the previous 16 swapped one. So how I'll get that one means my present iterations removed value is 5, right? 5 minus my previous iterations removed value, that is 2. So 5 minus 2 is 3. So 16 minus 3 is 13. Later in the next iteration, I'll do the same swapping crossly. So 13 is gone here and 14 is gone here. So how 14 is become 13 means, so since I have removed 2, 5, now I have to remove 6. So I have removed the 6. So 2, 5, 7, 8, 4, the leftover array. So now the presently removed value is 6. The previously removed value is 5. 6 minus 5 is 1. So 1. I need to subtract 14 minus 1, that is 13. So now I have found that 13 equals to 13. I have written the value. Same thing is written in the code. So n is the length of the planets list, Mosses list. So I declared the sum 1 and sum 2. These are the even and odd sums declared with 0 for I in range of n. So primarily I have calculating this sum 1 and sum 2s. So even index places and odd index places things means I% 2 means even index place. Sum 2 place. This means I% 2 equals to 1. So that's the odd place. But according to the question, index 1 is started. Nothing is problem. Even and odd should be equal. At the end of the problem, we need to evaluate whether even and odd sum equal or not, right? So that's not a big problem if we interswap the even and odd things. So previous value is 0. So I have declared the previous as 0. Why I have declared the previous as 0 means, so when I am in the first test case means when I have primarily removed the first value 2, so I don't have the previously removed value, right? So I have set that one to 0 means to get no value has changed, nothing to be changed in my answer. So minus 0 is nothing but 2, right? So for that case, so planets of I minus the previous, that is subtracted from the sum 1. If sum 1 equal to sum 2, at that condition I will return the index plus 1. Why I am doing index plus 1 means, since here considered a problem according to the one index is the index should be started from 1, whereas in Python nor in on any other programming language the index is started from 0. So I have so the reason why I have returning I plus 1, index plus 1. So if I haven't found that sum 1 and sum 2 are not equal, so I'll just swap that sum 1 and sum 2 as reverse, and I'll do previous is the present planets of I. So in the next iteration, my present planets of I minus the previous means the previous planets of I. So again, I'll check for sum 1 equals to same thing is happened. So in this, so we can reduce the time complexity to big O of n. Previously, big O of n square is being running means we need to calculate the sum for every we removed temporary array, right? So instead of that one, we are doing this. So this is the being explanation. So now I'll remove this thing. Once again, we'll check with the all test cases. So all are working fine. The big of and time complexity. So I'll submit it. So even I have solved the first one and I have explained the first one as well. Just I'm checking whether the all test cases are running properly or not. Just making a check. Yeah, fine. All are running properly. I'll submit it. So even I'll submit this one also before touching all test cases to make sure that you perform a double check. Yeah, now I submit this. So now I submit the test since I have solved the both two problems as well with all test cases. Okay, submit my test. Let's close this contest. Yeah. Okay. Now I stop here. Okay, now I'll stop recording.